Hello, and thanks for joining me again today. I'll be working on drakon again, or specifically drakon renderer. Um, let's transition to the code view. So we're starting with the drakon white paper. So it should be a pretty interesting, yet I think short session today. So I hope you have your coffee ready. I have mine ready. Let's kick it off. So during my previous sessions, I sort of suggested that I'm thinking about or starting to think critically about how my drakon diagrams are represented in text files. And I'm still thinking critically about that. And I'm not extremely pleased with how the layout engine is constructed right now. I will never be. That piece of code is very complex and it probably will never be perfect. But I'm still thinking whether I implemented everything to the best of my ability and to the best of the amount of common sense I have. And the answer so far seems to be no. So what I planned for today used to be to try and recreate the choice diagram from that video Stepan Mitkin prepared about primitive diagrams. I also wanted to start working on the troubleshooting mode being triggered by a flag. But now I'm thinking I went back to basics and I started reading this white paper again. If you haven't read it and you're into drakon, this is probably mandatory reading, and I think it's very, very good quality. So today's session I would like to devote to something different, though, and not to the troubleshooting mode, not to trying to recreate that primitive diagram, but instead to I would like to devote today's session to providing alternative data types for various elements of a drakon diagram. So see, I started building drakon renderer not knowing about this white paper even. I only saw some brief mentions of drakon diagrams on the internet. I saw the drakon hub and I sort of started playing with the concept, but it wasn't anything serious. But over time, I started really getting interested in the concept. Diagrams is something that I use in my daily work extensively. So it would be nice to incorporate drakon in my daily work and be able to visualize complexity and decision making and processes with drakon. Now, to go back to what I wanted to devote the session to today, my elements of drakon diagrams are called icons. But if you look at the white paper, the author uses a very elegant set of terms for various components of a diagram, and he compares the diagrams to a language. Truly so. The drakon is a visual design language. So he compares to these individual icons, which I also call icons in the current implementation of the renderer. He calls them letters of the alphabet, the visual alphabet of the drakon language. So we do have these letters already. Okay, or at least some of them. We have the title, we have the end, headline, action, etc., etc. Now, more complex shapes that are a result of combining these letters with valent points, which valent points come pre-installed. They're like batteries that come included in the set. So valent points come pre-installed here in these letters forming what the author calls words. And that makes perfect sense because what gets injected or into the diagram in place of those valent points are other words and other letters. And the reason I'm thinking about approaching the representation of drakon elements like that is because this should simplify layouting a lot. What my initial fear with layouts was that the connections would cross and icons would clash. But following drakon principles, I don't think that would really be possible. And really exploring that thought gets me back to the question, is the layout algorithm that I put in place really the most optimal? Is it really the easiest to understand and maintain to humans like you and me? And the answer is no, and it probably will remain a no, because it is undoubtedly a complex piece of code. But can we make it simpler? Yes, definitely we can make it simpler. So today's session, simply because it's Friday and I want to take this even easier than usual, I would like to come up with a handful of new types that would describe drakon letters and drakon words a little bit closer to what's defined in the white paper. Okay, so switching back to my code view. Oh, sorry, we're already in the code view. I was switching back to my records. We see that in my representation, a letter is an icon. And it's not incorrect, but it could be improved. See, it is very general, with technically an infinite list of dependents, and not and no supplementing properties, like, for example, the text that should be displayed beside a connection, etc. But anyway, what I'm tempted to do today is just to create an issue on GitHub that will focus on creating just a handful of drakon letters and a handful of drakon words. And let's see what happens. I also have a very old school printed copy of this here. So let's get here. So we need and a word. And let's start working on this. Okay. So first, let's focus on letters. And a letter will be really very similar to an icon, but, yes, thank you. But I wouldn't want letters to be very general. like this. In my implementation, icon describes anything, and connection is not even a type, I don't think. Yeah, it's not even a type, which I believe we can improve. So here, let's start with an alternative approach. So first of all, sorry. And we have a number of those letters at our disposal to be implemented. So let's start with the obvious ones, title and end. So the values will really be very similar. Oh, sorry. And because this no longer needs to be general, icon kind can be removed. And instead of having a list of dependent or names of dependent icons, we can just have dependent name. Which is just a string. Name, description, dependent name. And that is making the type very simple. Let's see if this compiles. Oh, we have some shadows. That is fine. It doesn't have to be super perfect. We'll deal with those shadows later. So we have the title letter. Also need end letter. They look very similar, but and does not need to have a dependent. And just as an exercise, let's add two more. Let's add an action. And And action also has one dependent. So dependent name, really, we can think of it as of a... Oh, sorry. So see, we're already making a mistake. So a title letter cannot have a dependent, because title is a title, end is an end. What makes a word is a letter with its valent points. And I'm not sure all valent points are listed here. Let's see. But the reason why I paused is if we represent letters like this, they're really all the same. They look the same. They will have a different shape, though. Let's leave them as they are. And now, let's remove this. Let's remove this too. And the positioned icon. Oh, this needs to change. These are clashing now. Oops. That's not what I wanted to do. I'm not looking for perfection here. I just want to start seeing more reasonable pattern. So with these 4 letters, let's start forming their words. So even though we don't have, say, a title and its valent point defined here as a word, I think it still qualifies as a word. Title word. And we'll need 1 valent point here. And this is where the complications start. So for just a plain isolated word, valent point is a sensible choice here. So a valent point is defined at the very top. It's not a letter though, and I already have a valent point defined somewhere, don't I? As a function and as a kind, I think. So let's call this a dependent. That is either a valent point I hope I'm using either right, but we'll get to it in a second. So it's either a valent point or a letter. And here we want a general letter. Oh, sorry. Not a general letter. We want a general word. So for now, this is in base. You know what? Let's delete all those letters. We know that with their current implementation, they're all the same. Let's just call it a letter. Oh no. I'm just thinking out loud. Let's see if this works. It does. Sorry about that. All right. It works. So what I really wanted to see is let's restore these letters. What I really wanted to see is how a word would look like for, say, a question. Just for the time being, let's call it question word. And now the question word has two dependents. Let's call it question left dependent and question right dependent. And this is the title. And they can both be of type either. So here, it's probably a good time to start wrapping the session up for today. So I'm just going to leave a comment for myself. And I think we'll finish on this today. I will keep thinking about those data types and about the new way of laying their visual representations on a 2D plane. But for now, yeah, I think exploring this direction, it feels healthy. It feels healthy to do. Right, I think we're going to wrap it up for today. I promised a short, relaxed session, and I believe I did deliver that. So I wish you a fantastic Friday and fantastic weekend ahead. I hope you get some time to relax and wind down, and I'll see you next time. Bye.